Hi, my name is Jim Recker, Fleet Technical Instructor for United Airlines. Let's begin this oral shun with the primary flight display. Let's start with the speed tape. We have a red and black barber pole. What do we call this?
That's Vmax.
And what does Vmax represent?
Vmax is based on VMO, MMO, VLE, or VFE, whichever is lower.
Okay, what occurs at Vmax?
Well, as we accelerate past Vmax, we're going to get a continuous repetitive chime, and we'll also get an ECAM with that.
If you accelerate through Vmax, we have these double green tick marks. What is that called?
That's called high-speed protection.
And what occurs at that?
That occurs at 6 knots above VMO or 0.01 above MMO, and we'll have an autopilot disconnect, the airplane will roll wings level, and uncommanded pitch up.
What if you continue to try to over-accelerate the aircraft?
If we continue to push forward, the aircraft would accelerate to VMO plus 30 or MMO plus 0.07. After we reach that, the nose would definitely come up and would decelerate to VMO plus 16, MMO plus 0.04. Once we slow down below Vmax, then the logic would be reset and we could accelerate back to VMO plus 30.
We have these magenta brackets. What are those called?
It's called econ descent range.
Okay. And how do you get these econ descent brackets?
Well, first of all, you have to be in descent mode. You also have to be in the descent phase of the MCDU. And then finally, you have to have managed speed.
Okay. In the econ descent brackets, what's our range of speed?
It's plus or minus 20 knots off of whatever we have programmed in the MCDU, unless we're below 10,000 feet. Then it's plus 5 minus 20 because we don't want to overspeed the 250 below 10 rule.
Okay. On the speed tape, we have a little green circle, which we call what?
Green dot.
And what does green dot represent?
Well, it's basically L over D, the best L over D, but it also represents ICAO holding speeds as well as our drift down speed.
Okay. And what kind of configuration would you have to be in order to get green dot?
You have to be clean.
Tape, we have an amber tick mark, which we call what?
VFE next.
Okay. It's sitting at 185 knots, so where are the flaps now?
Well, at 185 knots, our next flap setting would have to be 3, so that means our current flap setting would be 2.
Okay, let's assume that you go from position 2 to position 3. What will your amber tick marks go down to, and what happens to Vmax?
The amber tick marks go to 177 because our next flap setting is flaps full, and that number is 177. Vmax will then move down to 185 knots where the Vnext was before. And then if we're in the approach phase and all the autoflight was hooked up, we'd be flying at F speed.
We have S speed. What does S speed indicate?
According to the UAL flight manual, that's called minimum slat retraction speed. During takeoff phase, when we reach S speed and are accelerating through it, we can retract our flaps from position 1 up. But it's also used during the approach phase of flight. If I've activated the approach phase of flight and I'm in all auto flight, then the aircraft will slow and maintain S speed. The thing to remember that's a optimum speed to be flying, not the minimum. The minimum speed is VLS.
Now we have an F speed. So describe F speed for me.
F speed is basically the same thing as S speed, except for F speed is related to flaps 2 or flaps 3. It's called minimum flap retract speed because we have flaps out when we're in position 2 or 3. And during takeoff, as I accelerate through F speed, I can then raise the flaps from either 2 or 3 up to 1. And again, if I'm flying around in the approach phase and I have auto flight completely hooked up, I'll be flying at F speed.
Speed tape, we have a magenta speed bug. What type of speed is that?
That's a managed speed.
Okay. And that managed speed, could that be also a managed speed for the approach?
Yeah, it's a managed speed for basically any phase of flight. We regularly see it as managed approach speed.
Okay. Down to the horizontal yellow line. What is that?
That indicates on the tape itself the speed that we're actually doing right now.
And the vertical yellow arrow?
That's called our speed trend arrow. It indicates the speed that will be in 10 seconds if everything remains constant.
Okay. Is that always displayed then?
No, it'll display anytime acceleration is greater than 2 knots per second, and it disappears when acceleration is less than 1 knot per second.
Now we have a blue speed bug. What type of speed is that?
That's a selected speed.
Okay. And what would be that blue one?
That's V1.
The top block of our amber portion is called what?
VLS.
Okay, and VLS is what?
That's V is speed, so V lowest selectable.
Okay, if I come up to the FCU and I go select speed 100 knots, will the aircraft slow to that?
No, the aircraft, with all the auto flights hooked up and everything, the aircraft will slow to VLS. If you're an alt or alt star, it could go below VLS, but for most cases, we'd be flying at VLS.
The VLS that you find on your performance approach page on the MCDU, and it's in green. Describe to me the difference between this VLS and the VLS you find on your PFD.
Okay, the VLS down here is generated by the FACS. It's a dynamic number which changes quite regularly, and it's based not only on gross weight, but angle of bank, load, and all these other factors. The number up here, VLS, is generated from the FMGC and is based specifically on your gross weight. And all we really use this for is to develop what our V approach is going to be.
If you come down through VLS, we get to the amber bumblebee portion of the speed tape. Describe to me the top of that.
We call that alpha prot or alpha protection.
And what are you commanding in alpha prime?
Well, prior to alpha prot, when I move the stick, I'm commanding a load factor. When I get into alpha protection, I've got basically 4 protections that go on. We use the acronym ASAP, which is AOA is commanded, the speed brakes retract, the autopilot kicks off, and the pitch, nose up, trim is inhibited. We also are limited to 45 degrees back.
If you're in alpha protection and you let go of the side stick, what will occur?
When I let go of the side stick, the nose will fall to maintain the top of alpha prot.
So what positive input is required to get out of alpha prime?
I'd have to push forward on the stick.
If you were to hold full lap stick, you get to the red tape, which we call what?
Alpha max.
Okay, and what are you commanding in alpha max?
That's the maximum AOA that you can get with full lap stick.
Okay. Is there any other protections that you find
Yeah,
in normal law?
we've got 2 more normal law protections, or aids. One is a low energy warning. The other is alpha floor.
Okay, describe the low energy warning for me.
All right, low energy warning. We're going to hear it, and that's all you're going to do is you're going to hear it, and it's going to say speed, speed, speed. That indicates that the only way to get a positive flight angle is by adding thrust. If we pull up with our nose, we're not going to start climbing, so we have to add thrust. It's really something that's available only during the approach phase. If you read through the long laundry list of items that when this is inhibited, you'll see that it's inhibited above 2,000 feet, below 100 feet, or any time our flaps are not 2, 3, or full. There are several other inhibitions in there, but as you can see, it's basically designed for the approach phase.
And then you mentioned another protection, which would be what?
Yeah, there's alpha floor. An alpha floor, as opposed to a protection, it's really an auto throttle function. And what that does is if I have an operative auto thrust, I don't have to have it engaged, it just has to be available to me, and I get into a high alpha situation, thrust will go directly to toga without me even moving the thrust levers. And this is just a way to say, hey, I need thrust now.
Okay, what kind of indication will you get that you have alpha floor?
It'd be an FMA up here in the auto throttles column that says A floor.
Okay, since it's a function of the auto throttles, what are some times that alpha floor might be inhibited?
Well, anytime the auto throttles are not available, you're not going to have alpha floor. Those times would be if you've pressed instinctive disconnect for 15 seconds. If you go into N1 mode, you don't have auto thrust, and therefore you don't have alpha floor. Other times it's inhibited is anytime you're below 100 feet in the landing configuration, or on the 319 if you're in single engine and you have the flaps out of up.
If we degrade for normal law, we still have VLS, but now we get a red and black bumblebee. Describe that to me.
Okay, the top of that we call VSW. So V being a speed means V stall warning. Although stall warning really can occur anywhere in here.
I see a magenta 136. What is that?
That's a managed speed off scale. It's basically the same as this. These two are similar except for this is off scale low. We could also see it up here, off scale high.
Okay. And below it is a green .78.
And that's the Mach indication, and that's present only when we're Mach 0.5 or greater.
I see Dulles 110.10. Describe to me how you get that.
I'd have to select on the ILS indication here, I'd have to select the ILS push button, and that'll display not only the scales, but it'll display the identifier. It's important to remember that that's only going to bring up what it's decoding, not what you've entered. So if you've dialed in 110.1 and it's decoding ISGC, but you're looking for IIAD, it'll give you ISGC. So you need to make sure you have the right decoded identification.
What's this amber bar right here?
That's our lubber line. It basically indicates what our heading or track is.
And what about the green diamond?
That's our track diamond. That indicates what our track is across the ground. Since it's to the left, that indicates our drift is to the left, or our track is left. Let's say this is 3 36, this is 341, so that would be 5 degrees left, and the wind must be coming from this side.
Moving along, we have a blue upside triangle here. Describe this to me. What is that?
That's selected heading on scale, or could be selected track on scale if we selected that mode.
Okay, and then what would be the blue 270 here?
It's the same thing, but it's off scale. It's similar to the managed speed being on scale, off scale. This is an on scale, this is an off scale.
What about our magenta sword or dagger here?
That's the ILS course selection, and this is on scale, this is off scale.
Again, how would you get this display?
The ILS push button has to be selected on.
Good. In which case, we, as you said before, we get our raw data glide slope localizer.
Right.
Describe to me when you would get your RA, or radio altitude.
The radial altimeter comes into play below 2,500 feet AGL. It'll be green all the way down to 100 feet above whatever RA or decision height we have set in the MCDU. It defaults to 400 feet if you don't enter one, and if you enter no in there for whatever reason, it would turn amber at 100 feet. DH will appear anytime you're at or below your decision height set in the MCDU.
Describe to me the little blue line that you find on your horizon.
Should be in line right here with the heading selected, and that is only present whenever the flight vectors are biased out.
Okay, could that be a selected track?
That could be a selected track if you selected that mode, yes.
How do you bring up your flight director symbology?
The flight directors are displayed by selecting the flight director button on.
And what's commanding?
Right
the
now,
flight directors?
this is the pitch bar, and this is the roll bar. So this is currently telling me this is the fixed aircraft symbol to climb, and this is telling me to turn right.
What flight computer detects wind shear?
The FACS flight augmentation computers.
And what are the two other items that the FACS?
The speed envelope and the rudder inputs such as yaw dampening and turn coordination.
What's your yellow triangle up here?
That's the top part is the sky pointer or roll index, and the bottom part, the bottom trapezoid, is called the side slip indicator.
Okay, it's yellow, so it's a side slip indicator. Will that ever change colors?
Yeah, it could be blue when it's the beta target.
Okay. Now, would you still center beta target up?
Well, if you center up the side slip indicator, you're asking for 0 side slip. And if you have the beta target centered up, you're asking for the optimum side slip for the asymmetric thrust that's going on. Beta target's only available, we have a gauge called 1, 2, 3. When the flaps are 1, 2, or 3, the thrust is at least 1.25 EPR, and there's a greater, or 0.3 or greater difference of EPR between the two. So it's got to have an asymmetric thrust situation. So when you center up that beta target, you're getting the optimum side slip in there. Doesn't mean you have 0, it means you have an optimum side slip.
Go through the scales for me.
Sure, you've got 10, 20, 30, 45, and 67.
Okay, let's talk about the bank angle in normal law. For example, the green tick mark sitting at 67. What does that mean to you?
67 is the max bank angle we can get in normal law. I cannot command any greater than 67 degrees.
Okay, moving down, we have 45 degrees. What are some items in normal law that would limit you to 45 degrees bank?
If I were in high speed or in low speed protection, I'm limited to 45 degrees bank.
Okay, let's assume that you're in high speed protection, you've commanded 45 degrees bank, and you let go of the side stick. What occurs?
If I let go of the side stick, the aircraft is going to roll back to 0 because what it's trying to do is protect itself from over-G'ing asymmetrically.
What about on the low speed end when you've commanded 45 degrees bank and now you let go of the stick?
In low speed protection, it's just going to roll back to 33 degrees because it's not concerned about the over-G.
Okay, so with that in mind, any bank angle that's greater than 33 and you let go of the side stick, what occurs?
It's going to roll at least at 33 degrees.
Okay, what about a bank angle between 0 and 33?
If I'm between 0 and 33 degrees and I'm not in high speed protection, it's going to maintain whatever bank angle I have.
Anything that might occur at 33 degrees bank and beyond?
Beyond 33 degrees bank, I'm going to lose auto pitch trim. And once I get to 45 degrees, I'm going to lose the autopilots and the flight directors.
In normal law, describe to me some pitch limitations. For example, pitch up and pitch down.
Okay, as opposed to pitch left or pitch right?
Exactly.
Okay. Maximum pitch we can get on this aircraft in normal law is 30 degrees. As we get to 30 degrees, energy is going to deplete, and then it'll be limited to 25 degrees. That's true for all configurations except for flaps full. In flaps full, we're limited to 25, and as energy depletes, it'll decrease to 20 degrees. nose down, regardless of the configuration, the maximum is 15 degrees.
Okay? And what indications will you see that you have that protection?
You'll see green tick marks at 30 and green tick marks at 15, just like these green tick marks.
What other protection do we have available, for example, G protection in normal law?
We have load protection in normal law, and that is 2.5 degrees positive to -1 when we have clean or slats. If we have trailing edge flaps out, that range is limited to 2 degrees, 2 Gs, and 0. That protection is available in normal law, and it's available in alternate law. Once we get out of alternate law, those limits still apply, but they're no longer protections.
How would you degrade for normal law?
You could degrade 2 different ways. One is the catchphrase, multiple failures of redundant systems. The other way is by getting into an abnormal attitude configuration.
Starting with degrading into alternate law, what would be some specific indications that you're in a degraded flight control law or even alternate law?
The easiest way to determine that you're out of normal law is by looking for amber X's that are here. And that looks like this.
Okay.
But there's other indications that you could have. For instance, we no longer have alpha prot and alpha max, we have VSW. We also lose the green tick mark up here as well as at the pitch.
And what would specifically tell you that you're in alternate law?
The ECAM will come up and say alternate law protections lost.
Is there any mode that you might not have available or that you don't have available in alternate law?
You don't have flight or flare mode.
Okay. There's an alternate law that's called alternate with speed stability and alternate without speed stability.
They're basically the same thing. The only difference, and you're not even going to be able to tell from your aircraft, you just have to know a specific fault is going to cause that. But if you have stability, when you get slow, the nose is going to pitch down slightly to keep you from getting slow. If you get fast, the nose will pitch up to keep you from getting fast.
Can you override that protection?
Absolutely.
You go gear down on the 320, you're in alternate law, what will occur?
Gear down with the autopilot off, and you're going to get into direct law.
Okay. How would you know that you're in direct law? What are some visual indications?
Easiest one is it's going to come up and say use man pitch trim. Of course, probably even easier to look down at ECAM and it'll say direct law protections lost, but an easy way is to see man pitch trim.
And do you have any protections available in direct law?
There are no protections. You have VSW, that's not a protection, that's just an all warning.
You get this red man pitch trim only. What law are you in then?
That gives you mechanical backup.
And what are some items that you have available in mechanical law?
You have manual pitch trim, as it says. You also have 2 other things. You have your rudder pedals, which are connected to cables, which are connected to hydraulic actuators, which allow the rudder to move. You also have thrust capability. People say asymmetric thrust, which really doesn't do much for you, but the thrust really does play a major factor in pitch. With the low slung engines that we have, if you add thrust and the lever arm that it gives you, it'll give you a pitch up. If you pull thrust back, it'll give you a pitch down.
Finally, there's another law called abnormal attitude law. If you have these protections available for bank and pitch and so forth, how would you ever enter this abnormal attitude law?
Well, you definitely can't get there yourself. You have to be put there from some outside source, such as a wingtip vortice or wind shear, some kind of outside force causing the airplane to roll or pitch up.
And what kind of parameters would you have to exceed to get into abnormal attitude law?
Well, an easy rule of thumb is just double whatever your maximums are. For instance, our pitch up, we said it was 30, 25, 20. 25 is the mean in there, so just double that, 50. Pitch down, we said it was 15, double it, it's 30. Roll, 67 degrees, double it, that's roughly 125. And then there's some speeds in there which people usually don't ask, but it's 440 and 0.91. If you go faster than that, if you go slower than 60 or 0.1.
You've entered abnormal attitude law and you recovered. Do you go back to normal law?
No, you definitely don't go to normal law. You go into something that's very similar to alternate law. The big difference, you're definitely going to have stability, you're going to have yaw dampening, but the biggest difference is that you get flare mode back.
Let's move over to our barrel reference. We're approaching a selected altitude. How many feet prior to the selected altitude will the yellow outline box flash?
750 feet.
Will you get an altitude alerting?
Only if you're hand flying. If the autopilot's on, you don't get an alert.
Okay. You're at the selected altitude and you deviate more than what, the box will turn amber.
It's 250 feet.
Will you get the altitude alerting then?
Yeah, anytime you deviate by more than 250 feet, regardless of the autopilot, you'll get an alert.
Is there any other time that the numerical value might go amber?
Yeah, it's similar to the whole decision height and problem down here. When you descend below an MDA that's set in the MCDU, these will turn amber.
Over to our IVSI. When do you start getting a numerical value?
Anytime it's greater than 200 feet per minute.
Okay, would the pointer and the numerical value ever go amber?
Yes, anytime you have an excessive vertical speed.
What about the condition in which you only get an amber box around the numerical value? What's occurred here?
Well, this is usually IBSI, which is done by the IRs. But if you lose IBSI and go to just regular VSI, the ADRs are now supplying a barometric reference for that.
Okay. I see down at the bottom a blue box around 28,000, flight level 190. Can you describe?
That's a selected target altitude that's selected on the SCU.
And could you ever, so you could get above or below?
You could get, yeah, oh yeah.
Finally down here, 29.94, the QNH.
This is your reference for your altimeter setting. If you're above the transition altitude, which we are in this case, this should be, we should get flashing, and we'll go to a standard, and we'll have to do what to push, or pull for standard, it should be push. We have to pull for standard here. If we are below our transition altitude and we still have standard selected, we'll have to push and then give whatever barrel reference we want to set for it.
We have an amber ILS. Let's assume this is flashing at you. What's occurred?
Flashing ILS indicates to me that in the McDo I've selected an ILS approach, I've selected the approach button on, which is over here, and I have not selected the ILS display. Basically, all this is telling me is that I've told the box I want to fly an ILS, I have commanded the ILS to be flown via the approach button, but I don't have raw data displayed.
What would occur on a non-precision approach?
On a non-precision approach, there's a similar function. It's a VDEV. We normally get a magenta VDEV up here for an approach nav approach, but if we're a flashing amber VDEV, that indicates a similar situation. It indicates that I've selected a non-precision approach in there, but I have the ILS push button displaying the glide slope. Glide slope take precedence over anything else, so we couldn't see the raw data for the approach.
Along to our magenta donut. What do we call that? And what's it displaying?
It's the vertical navigation deviation indication, VNAV deviation, or magenta donut, which is what we really talk about it. And what it tells us is, from our vertical navigation path, the VNAV descent path, it tells us how far off we are. The scale is plus or minus 500. We can see a little more detailed or a more accurate version of this on the prog page, but it doesn't give us a graphic definition. This is also similar to the VDEV, whereas if we're on the approach nav approach, it's still a VNAV deviation, but it's a shoebox, and it is now 200 feet instead of 500. Big difference here between the ILS and the vertical navigation stuff. This is a very linear type of display. It's always 500 or 200 feet all the way down, whereas if you've got the glide slope, it's a angular. In other words, as you get closer, the constraints get tighter and it becomes more sensitive.
Our flight mode enunciations. Let's start with the first column. What modes do you get in the first column?
That's the auto thrust mode.
What about the second column?
Vertical, lateral,
Four.
the approach capability, and the auto flight status.
Looking at the FMAs, can you describe what's going on with the first three?
Yeah, we're in an approach nav approach. We've got final arms, so we're not yet up to the pseudo glide slope. We've got approach nav engaged, which means the LNAV portion of it is engaged, and we are just now coming on to our final approach fixed altitude.
Can you go into detail the last two columns?
Yeah, looking at this stuff, with a Cat 3 single, we could be going down as low as a Cat 2 approach. But when I see the MDA 350 in here, an MDA means a barometric reference, which is for a Cat 1 approach. Cat 2 would require a DH of something to be set in there. So we must be doing, with the autopilots coupled here, I'm guessing we're going to be doing a Cat 1 autoland.
Staying with the ADI, what's this green pointer?
That's called the Washington Monument.
Let's be more specific.
That's the Ground Roll Guidance Command Bar.
Is that always displayed?
No, only in DCA or Dulles. Actually, it's displayed only on the ground up to 30 feet during a landing or a takeoff on a runway with a localizer.
Okay, so it's receiving a localizer signal. Is that true that if you stay on it, it's going to drive you down center line?
If you're on it, that means you're on an appropriate heading to intercept the center line, or that you are on center line. We basically call it steering information instead of raw data.
And what if you were to lose the localizer?
If you lost the localizer, but it had received it for a reasonable amount of time, it would memorize the path and still give you the information required.
What about the flight director symbology you see up here? What do we call that?
Okay, this is the flight director, and it's the flight path director. We just call it flight path director because it's referencing the flight path vector. We get this display whenever we select the track flight path angle display. We're only allowed to use this when we're VMC. Right now, this is telling us that it wants us to be in a right bank, and because it's above the horizon line, it wants us to climb. Well, actually, because it's above the flight path vector is the climb that's going on. Okay, so this is telling us to pull up and turn right. Right now, the flight path vector, because it's above the horizon line, about 1.5 degrees, means that our flight path from the horizon is climbing 1.5 degrees. Also, because it's is the right of the center line, that means we are drifting to the right, and we must be having a wind from the left side.
What about the plus sign you see here? What does that represent?
Side stick's order indication.
Is that on side or is it the sum?
It's a sum of the two. So in other words, if the captain moves his, the co-pilots will move as well. And if they kind of play around with the sticks, it takes a sum of both of them. So if the captain pushes forward 5 degrees and the co-pilot pulls back 10 degrees, it's going to come back 5 degrees total.
What about the boxes that you see on the outside?
That's just the maximum range for that side stick order indication.
Again, here we can see an example of beta target in blue.
Yeah.
Start with the auto throttle column FMAs. Easy way that I remember it is that everything above my hand is arming range or arming modes of the auto throttle, and below my hand is engagement modes of the auto throttle. So starting with the top, how would you get Mantoga?
Mantoga means that the auto throttles or auto thrust is armed, and the most forward throttle is in, or thrust lever is in the toga detent.
What about man flex?
Man flex indicates a couple things to me. First of all, it indicates that the auto thrust is armed, that the most forward thrust lever is in the flex detent, but it also indicates I'm on the ground because this is during takeoff, and it indicates that in the MCDU I've set a flex temperature of 42 degrees.
Let's say you forgot to set that flex temperature or that assumed temperature into the MCDU. You get the throttles to the flex detent. Would anything occur?
Yeah, after about a second or two, I'm going to hear a single ding, and then there's going to be an FMA up there that says flex temp not set. Appropriate response would be to shove both throttles up to the toga detent. However, if I didn't recognize that and I was wondering what was going on, I pulled the thrust levers back to idle, I'd want to continue with the abort, even once I realized it, because we don't know the performance at the point that we're at on the runway.
Man flex and man MCT are the same detent, so how would I get man MCT?
Man MCT is only in flight.
Okay. Would that be a single engine FMA?
No, it's 2 engines, and it means that the auto thrust is armed and the most forward thrust lever is in the MCT detent. If I were single engine and I had that same situation, it'd be engaged because the engagement range changes to the MCT detent instead of the climb detent.
What about man thrust?
Man thrust is, the auto thrust is armed. The most forward thrust lever is forward of the climb detent, but it's just not in any of the other detents. It's basically a default for, hey, I'm not in anything up here, so this is what you get.
Let's move down to the engagement modes. Thrust MCT.
Thrust MCT means that the operative thrust lever is in the thrust MCT detent, and the auto thrust is, or in the MCT detent, and the auto thrust is engaged.
And it's commanding?
It's commanding MCT thrust only.
What about thrust climb?
Thrust climb means that the most forward thrust lever is in the climb detent, and the auto thrust is engaged. You get climb thrust only.
Moving down to thrust idle.
Thrust idle just means that the auto thrust has been commanded to idle thrust and idle thrust only. It doesn't mean that the thrust levers are in the idle detent. Typically, the way we operate this aircraft, the thrust levers are going to be in the climb detent. But the thrust has been commanded to idle and nothing but idle.
And what about thrust lever?
Thrust lever kind of falls in between thrust climb and thrust idle. What's going on is thrust climb has been commanded, but instead of having the most forward throttle in the climb detent, the most forward throttle is after the climb detent, which is limiting the thrust that's available. And what the thrust that you're getting is, with the TLA, the thrust lever angle that's right here, since it's moved back, that's the most thrust that it can give. So it's giving you that much thrust, but it's only giving you that much thrust. No less and no more.
Speed Mach. Explain those FMAs to me.
Speed Mach is completely different from these other engage modes. Speed is the only mode where you have a range of thrust available. In all these other cases where it says thrust MCT, or thrust climb, or thrust idle, or even thrust lever, you are only getting the thrust that's named there. I have MCT thrust only. Down in speed, I get a wide range of thrust. And let's just talk normal operations, where I have the thrust levers in the climb detent. Speed gives me a range of thrust anywhere between climb and idle thrust. If I have idle thrust, it's not going to come out thrust idle, it'll still say speed. If I have climb thrust, it's still going to say speed. And it has the ability to give a range of thrust anywhere in there. And Mach is basically the same thing as speed, except for in Mach, it's referencing a Mach number. Speed, it's referencing an indicated airspeed.
Alpha floor. You talked about alpha floor occurring. When would you get toga lock?
Toga lock will always follow alpha floor. Toga lock occurs once you are in the high AOA condition and have broken it, and then toga lock enunciates.
How would you get rid of toga lock?
Well, the mechanism by which disconnecting toga lock is just disconnecting the auto thrust. But we have a technique of moving the thrust levers up to the toga detent, disconnecting the auto thrust, and then moving the thrust back to wherever we want. We typically finish it off by going to the climb detent and getting the auto thrust on.
How does toga lock differentiate from thrust lock?
Well, toga lock is just as I described. It's an alpha floor function. Thrust lock, though, is when you've had the auto thrust engaged, and while it was engaged, the auto thrust function failed. It'll then leave the thrust at the last set EPR.
How would you get rid of thrust lock then?
Well, it's going to be up there flashing and dinging until you move the thrust levers. The second you move the thrust levers, the thrust is going to try to match where the TLAs are. So the technique is to take to read what EPR you have, in this case 1.056, and then move the thrust levers back to match that EPR. The thought being that if I was stabilized at 1.056 before and it's stable now, it's going to be stable for me when I get there. So I bring the thrust levers back and match the EPR to the TLA, or the TLA to the EPR.
Lever climb, lever MCT. Describe those for me.
Basically, it's just the computer saying, hey, you need to move the thrust levers to the specific detent. In most cases, we're seeing lever climb.
When would you get lever climb, say on takeoff?
Lever climb is going to occur during diff rips, we're going to set on the performance takeoff page, we're going to set the thrust reduction, acceleration altitude. At the thrust reduction altitude, lever climb is going to flash, reminding me to move the thrust levers from either toga or flex into the climb detent. And just kind of as an aside, the acceleration altitude that we enter in there is where open climb is going to automatically do it. On an ICAO procedure, we typically do this at 800 feet. On a standard nose abasement procedure, it's at 800 feet. ICAO, we do it at 1,500 or 3,000, following the profile that's in the book.
Well, if you modify the thrust reduction to give you lever climb and 800 plus feel for takeoff, what occurs on a go-round?
A go-round, that occurs at 1,500 feet. That's the default value, and you could actually, if you wanted to, scroll all the way to the go-round phase and modify that if you wanted to.
Finally, lever asymmetry.
Lever asym just tells me that there's a split in the thrust levers. And really, that's a small split. If you move it just a little bit, you're going to see lever asym. If you bring the thrust lever back enough, though, like more than a half knob width, it's going to think that it's in a single engine situation, and it's going to direct you, instead of a lever asym with the thrust climb, it give you a lever MCT telling you to, hey, put the good thrust lever in the MCT detent, and it'll give you a thrust MCT.
Vertical modes. SRS. Explain SRS to me.
SRS is Speed Reference System. What that means is it wants you to climb at a speed, and it's referencing a particular speed for each phase of flight. During takeoff, that's V2 plus 10. During a V1 cut, however, that's V2 or the airspeed that I am currently doing, whichever is greater. You got to remember that kind of goes against what our profile says in the flight manual. Our profile says that we need to climb out at V2 plus 10. SRS, though, if we got to V2 plus 30, it'll command V2 plus 30. So we need to fly V2 plus 10. The other thing to remember about SRS is that it will never command a level flight. It'll give you at least 120 feet per minute climb. And then the last scenario would be on a go-around. It'll give you V approach or whatever your current airspeed, whichever is higher.
Outstar and out. What is that?
Well, on all the modes, wherever it says start, that just means capture. That means it's just about ready to engage this mode. It's like a pre-mode there. With altitude is basically out hold for any of the other airplanes that we've flown before. And it means I'm going to hold whatever altitude I have set in the SU window.
What about out cruise then?
Well, out cruise is basically the same thing. It's an out hold, but instead of just engaging the altitude at the FCU, it's going to be engaging an altitude that's in the SU as well as the cruise altitude set in the MCDU. Big difference between out cruise and out, though, is out hold, or out, is a hold at a specific altitude. Out cruise, though, gives you a plus or minus 50-foot window that allows the thrust to be a little more stable, which supposedly gives the passengers a smoother ride, or a more comfortable ride.
Out constraint.
Out constraint is rarely seen at United. As a matter of fact, it shouldn't be seen at United because we have a policy of setting the most restrictive altitude in the FCU window. But to talk about altitude constraint, what this is used during a VNAV or VNAV climb or descent. And let's just talk about descent mode or climb mode because it's just an easy one to start with. If I'm at 5,000 feet and I have a constraint at a waypoint of 10,000 feet, but I go and select 15,000 feet in my FCU window, I'm climbing in climb mode. When I get to the 10,000 feet, it will level at 10,000 feet and I'll get altitude constraint. I'll also have an armed climb mode there. I will cruise then at 10,000 feet, even though I have 15,000 feet in the window, until I reach the constraint waypoint. Once I'm no longer constrained at altitude, it'll automatically re-engage climb mode and climb up to fly to the 15,000 feet. If it encounters any other constraint in there, the same thing will happen. It'll level at that constraint altitude, the out constraint will be engaged, climb mode will be armed until it's no longer constrained and can climb up. Once it reaches the FCU altitude window, it then goes into alt.
How would you get a selected vertical speed?
Selected vertical speed is done by pulling the vertical speed knob here. And what that gives you is a reference to a vertical speed. If I want to constantly descend at 500 feet per minute, as this indicates, then I'll pull and ask for that. I could ask for a climb as well, but it's just giving me a speed or a vertical rate of climb.
What about FPA then?
FPA is similar. It's referencing a constant descent or climb, but instead of referencing a feet per minute, it's referencing a glide path. The only way we can get that is by being in the track flight path angle mode down here, and this currently indicates heading vertical speed. But if we had track flight path angle, we could say, I want to descend 3 degrees per minute. The big advantage of this is, on a glide path, we want to descend just like a 3 degrees, like a VASI would be, or most ILSs are set up for. So we would descend constantly, as opposed to a vertical speed, which is a good wag. You know, we wag about 750 feet per minute, it's going to be that. But as tailwinds and headwinds play a factor, and our airspeed plays a factor, that vertical speed really is going to vary. With a flight path angle, it'll be a constant rate.
Expedite climb, expedite descent. How would you engage those modes, and what do they provide? What's the difference between the two?
Okay, it's done by the same button, the expedited button, which is installed on United aircraft and some of the other airlines. But when I press this button, if the altitude in the SU window is higher than my current altitude, it's going to give me an expedited climb. If it's lower, it's going to give me an expedited descent. And what this does is, it means I want to climb at a specific preset speed or descend at a specific preset speed. And that's going to appear as a managed speed in the speed window. During expedited climb, it's going to climb at green dot. Problem with green dot is that's really slow. Now, yeah, it's L over D, but we don't want to be getting down to 210, 220 knots. So an easier way is to do an open climb at about 250, 240. You can figure it out, you're a big guy. The expedited descent then references 0.80 or 340 knots. If you would happen to, for whatever reason, while you're in an expedited mode, pull the speed knob and select something else, you're going to revert to either open climb or open descent, whichever is appropriate.
Glide slope? Glide slope start?
That just means it's engaging the glide slope. It's received the glide slope signal and it's just going to fly the glide slope down. Works similar to the flight path angle, actually.
Describe to me open climb versus climb.
Okay, open climb means to climb at a speed. Whatever is, a phrase that we use is a commanded speed, which means it doesn't care if it's selected or managed. It's going to climb at whatever speed I have set here. Okay, that's open climb. Climb mode does basically the same thing, but it'll obey the constraints that are set in the VNAV profile. Unfortunately, at United, because we operate with the most restricted window in the SU window, climb and open climb are treated the same here.
Then what would be the difference between open descent and descent?
Actually, it's a real big difference. You'd think that if these were similar, these would be, but they're not. Open descent is similar to the open climb thing. Open climb means climb at whatever speed I have commanded. Open descent means descend at whatever speed I have commanded. Descent, though, doesn't really mean that. It means follow a VNAV path. And VNAV in Airbus EDs is very different than VNAV in Boeing. In a Boeing, it's basically a flight idle descent for every step. In Airbus, it's not. In Airbus, we do a flight idle descent to our first constraint, but after that it does what's called a geometric descent, which says if I need to be at this altitude at this point, and I only need to be 1,000 feet lower, 50 miles away, it'll calculate a constant descent down to that path, which is very different from the way you used to operate in the Boeing, which means open descent and descent mode are very different from each other.
How would you engage these VNAV climb or VNAV descent? What modes would you need?
Well, first of all, I'd have to have nav mode engaged. And after that, I'm just going to go to the lateral button right here and mash it, push, to get climber descent.
Let's combine auto throttle engagement to some of our vertical modes.
Okay.
Start with out cruise, out, and out constraint. What kind of auto throttle engagement mode would you have?
Okay, they're basically the same. We're just trying to hold an altitude there, and we don't know what thrust that's going to take. Is it going to take climb thrust? Definitely not climb thrust to maintain it. I mean, unless we're at our maximum altitude. Is it going to take idle thrust? No. If we have idle thrust, we're coming down. So it needs some thrust in between there, and the only one of these that can give me that is speed mode. So all the outs are associated with speed.
Vertical speed and flight path angle.
Well, they're maintaining some kind of flight path, either a variable type of vertical speed or some kind of flight path angle. To do that, we don't need just idle thrust. It may take idle thrust, but we don't know that we need it. And to descend, we definitely don't need climb thrust. We may need it for some type of climb, but the fact of the matter is it needs some kind of thrust in between typically, so it's going to need speed.
Glide slope's engaged. What mode would you get in the auto throttle column?
It'd be speed. It's just like a flight path angle, so it needs to use a varying range of thrust, so it would be glide slopes associated with speed.
About open climb.
Thrust climb, open climb. Open climb is only done at climb thrust, so it's thrust climb.
Open descent.
Thrust idle, open descent. Open descent is only done in an idle thrust, so it's thrust idle.
What about VNAV climb or your climb FMA?
Climb is the same thing as open climb for us, so it's going to be thrust climb. Regardless of whether or not you're using the FCU properly, the climb mode will be at climb thrust.
Descent?
Descent's the only one that's kind of tricky up there, and it uses thrust idle or speed, depending on what phase of descent it's in there. It's the only one. Every other one is associated specifically with one auto thrust mode.
On your lateral modes, the third column, what does runway indicate?
Runway indicates that you are, during takeoff, on a runway with a localizer, and you have that runway selected in the MCDU. From takeoff roll to 30 feet, it'll indicate that it's giving you guidance off of the runway localizer.
So would you get this symbol as well?
Yes, if you're doing a takeoff out of National or out of Dulles, out of any runway that's got a localizer we've selected, we'll get runway.
What about heading?
Heading just means I've pulled for a selected heading, or I've gotten myself into a version where a heading mode has come up, and I'm referencing whatever is selected heading.
Track?
Track's the same thing, except for now I'm in the track mode instead of the heading mode. I mean, it means that I've selected, instead of track flight path angle on this button, I've selected track, so now I have to reference a track as opposed to a heading.
Loc star and loc.
Just means that the localized portion of the ILS system has been engaged.
How do you know you have LNAV engaged?
It says nav mode, nav.
And what is it referencing in nav mode?
Nav's referencing the flight plan in the MCDU.
Runway track?
Runway track is, after 30 feet, it memorizes the path that we took along the runway, and then it presents us with a flight director display to maintain that extended line. Runway track's available on all runways, regardless of whether or not it has a localizer. The only time we won't see runway track is if we forget to, or intentionally don't, set a heading in here during our pre-flight. If we select runway heading or whatever our first turnout's going to be, we're basically de-arming nav. If I didn't de-arm nav, not only would I not have a heading in here, but I'd also have a blue nav on the second line.
What about go-around track?
Go-around track's basically a similar thing as a runway track, whereas on the runway track during takeoff it memorized that path. Go-around track has memorized the last path that we took before we selected toga on the missed approach. Go-around track is pretty sloppy because you got to realize that you're not necessarily flying down runway path, so your go-around track is not real reliable. So we want to get either heading or nav mode as soon as we can.
Approach nav?
Approach nav is just the LNAV portion of the approach nav approach has been engaged.
Fourth column, approach capabilities. We have Cat 1, Cat 2, and Cat 3, and then you have on your second line a single and a dual. Explain to me the modes that we get on the Airbus.
Okay, we only get 4 really. We get Cat 1, Cat 2 alone, or Cat 3 single, Cat 3 dual. We'll never get Cat 3 without a single or dual, and we'll never see single or dual associated with Cat 1 or Cat 2. Cat 3 single means we can shoot a Cat 3 approach and autoland. So, Cat 3 dual, we can shoot a Cat 3 autoland approach. Cat 3 single, we can shoot a Cat 2 autoland approach. Cat 2 means we can shoot a Cat 1 non-autoland, and Cat 1 means the same thing. Cat 1 non-autoland.
What about the decision height, no DH, and MDA?
Decision height and MDA, they had good intentions, but decision height truly means radio altimeter, and MDA means barometric altimeter. Now, the intention was that these were going to be for all the decision height approaches, but unfortunately, the only approaches we reference an RA on are the Cat 2, Cat 3 approaches. We reference the Cat 1 decision height as a barometric altimeter setting, and that's what MDA would be. It'd be an MDA for a Cat 1 ILS. The no on no DH indicates that somebody has actually set NO as a decision height, and that's something we don't use at United.
Fifth column, AP1 and 2, AP1, AP2.
AP1 and AP2 indicates that either Autopilot 1 or Autopilot 2 is engaged. AP1 plus 2 indicates that both autopilots are engaged, and that can only occur during an ILS approach after the approach button has been armed.
Second line, what is that telling you when it says 1 FD2?
1 FD2, the first column indicates that the captain's situation, the second column, or the right column, indicates the first officer's. When a number appears there, that means that the captain's flight director has been selected on. The number that's present tells you what system has been commanded. So in this case, the captain's flight director has been selected on, and the number 1 system is providing the information. On the 2, on the right side, means that the first officer's has been selected on, and the number 2 system is providing the information.
What about 1 FD dash?
1 FD dash indicates that, again, the captain's flight director is on, is being commanded by flight director 1, but the first officer's flight director has not been selected on.
1 FD1?
The captain is on, and number 1's commanding his system. The first officer's is on. Number 2 system is inoperative, so he's going off of flight director 1.
Is there ever a scenario that you wouldn't see?
Yeah, you couldn't see two FD1. The reason for that is, if they're both on and they're both operative, the captain's going to get number 1 and the first officer is going to get number 2, and you can't force it any other way. So if they're both available and both on, 1 FD2. If you had 2 FD1, that would indicate that they're both on, the captain's got number 2 and the first officer's got number 1, and that just can't happen.
Auto throttle in blue versus auto throttle in white.
Auto throttle in blue is that it's armed, auto throttle in white, it's engaged.
Let's move back to both columns of the vertical and lateral modes. And let's start with the land FMA.
Okay, land says that flare mode is insured, and it occurs at 400 feet. During an auto-land approach, it can occur no later than 350 feet.
What about rollout?
Rollouts, just after you roll out during the auto-land approach, it's basically referencing the localizer, and it's providing autopilot inputs to nose wheel steer the aircraft down the runway.
Flare?
Flare occurs at 50 feet, but during an auto-land approach has to be enunciated no later than 30 feet.
Final approach?
Final approach is a combination of final and approach nav, and it just means that the entire portion of the LNAV VNAV portion of the approach nav approach is engaged.
And what about the items that you see in blue down here? For example, blue alt, blue glide slope, blue loc.
Those are armed, and they're on the second line, and they just mean that those modes are armed.
Panel. I like to break this down into simple terms, and the way I remember it is Aileron number 1 is for the captain, Aileron number 2 for the first officer, and 3's in the middle as a standby. Remembering that all 3 IRs provide a mixed IRS position input to the flight management guidance system. Now let's break down IR information versus ADR, realizing that Chapter 19 of the United Flight Manual goes into more extent of each one. I remember IR provides attitude and heading, and your IBSI. ADR is nothing more than pitot-static converted into an electrical signal by the air data module. That provides your speed and barrel reference. So based on that, let's talk about some malfunctions. You lose the captain's attitude and heading. What's failing?
The IR, number 1.
You look at the overhead and you see a flashing fault line on IR1.
That indicates to me that heading and attitude may be recoverable.
Same scenario, you've lost attitude heading, but this time you look up and it's a steady fault line.
That means the IR is kaput.
Okay. Either scenario, ECAM's going to direct you to do what?
It's going to direct me to come down and take attitude heading captain on 3.
Now you lose the first officer's speed and barrel reference. What's failed now?
ADR 2.
You look at the overhead, you see a steady fault line and ADR number 2.
Yep, I see that.
That's an indication of what?
That ADR 2 is failed.
How would you get that information back to the first officer?
On this panel, I would select air data, first officer on 3.
You told me that with a flashing fault light on IR1, the attitude heading information may be recoverable. Where would you find that procedure, and how would you recover the information?
Well, it's a non-ECAM procedure. It's going to be found in the irregular section of the United Flight Manual. But basically what it's going to tell you to do is maintain straight level flight, select attitude on the affected IR, come up here to heading, select the position, whatever one, and we're using number 1 now, so I'd select 1, press H for heading, and then enter a 4-digit number, which is a 3 integers and 1 decimal place. For instance, if I looked on the Whiskey Compass and I saw we were doing 265 degrees, I would enter 265 and then 0 for 0 tenths. I can't read a tenth on that. And then I'd hit enter. That's going to come up here and give me my magnetic heading up there. You got to realize though that if I look for number 3 or number 2, it's going to tell me a true heading as opposed to a magnetic heading that I'm entering.
On bat light, what are some conditions in which you get an on bat light?
Well, The one that we see all the time is anytime we turn them on, because when I turn on 1, 2, or 3, the on-bat light comes on telling me that the alternate source for it, which is the batteries, is picking up the ADIRs. But in flight, if I look up there and I see an on-bat light, that indicates that one or more of the ADIRs are on the battery power.
3 conditions for flashing a line light. What are those conditions?
Well, the one we typically see is during the pre-flight, we've come in and we've turned on the ADIRs, but we haven't in a present position within 10 minutes. The other reasons are an alignment error, or if I've entered a position that is more than 1 degree latitude or 1 degree longitude off of the last known position.
Is there a way that I can leave the IR running but turn off the ADR?
Sure, the switch down below here, these are switches, so I can select the ADR off without selecting the IR off.
Is there a way that I can turn off the IR portion but leave the ADR running?
No, if I select the IR off, the ADR is coming off as well.
Flight controls. Above the captain we have ELAC 1, SEC 1, FAC 1. Above the first officer we have ELAC 2, SEC 2, SEC 3, and FAC 2. What are the ELACs control?
ELACs control the elevators and ailerons. ELAC 1 primarily controls the ailerons. ELAC 2 primarily controls the elevators.
SECs.
The SECs control the spoilers and the elevator.
Let's say ELAC 1 fails. What would occur now?
ELAC 2 would back it up.
What if both ELACs should fail?
If both ELACs fail, the SECs will back them up. But in the roll, it can't back up the ailerons. It can only do the spoilers.
FACs. Flight augmentation computers. You described to me the 3 things that the FACs do. So let's move to fault indications. You get a fault in an ELAC.
Fault in an ELAC is like a fault in any of the computers. It indicates that the computer has failed. A fault in the ELAC, though, will occur during the test that occurs during the first power-up.
EVAC. You have a red EVAC on the command button. Describe to me what this command button with the EVAC means, or selecting the on.
EVAC means that an evacuation has been commanded. On indicates that I've selected it from the cockpit.
What about this horn shutoff?
That just means that if an evac is being commanded, either from the front or the back, I want to silence the horn from the cockpit. Only the cockpit horn, though.
Then you have a switch that's safety wired. It says captain and purser.
When it's in the captain purser position, which it's safety wired to at United, the captain and the flight attendant either of them can start the evacuation. Theoretically, when it was selected the captain only, it was basically wiring out the flight attendant from being able to initiate the evacuation. Although it's wired to Captain Purser at United Airlines, for the last 3 years, maintenance has deactivated the switch, so we couldn't even select a captain if we wanted to.
Emergency electrical power panel. There's a guarded switch that says emergency gen test.
That's for maintenance use only.
Gen 1 line. You get smoke in the Gen 1 line switch. What does that indicate?
There's smoke in the avionics bay. It's going to be associated with a blower fault and an extract fault as well.
What occurs when you select the switch to on?
The generator 1 disconnects itself from the AC bus 1, and it allows the number 1 pump in the left and right wing tanks to be powered from the generator.
Well, assuming that generator 1 is now only powering the fuel pumps in the left and right, what will generator 2 do?
Generator 2, without selecting the bus tie off, generator 2 is going to power AC bus 1 and 2.
And what are we setting ourselves up for?
We're basically isolating ourselves with the avionics smoke configuration. We're going to isolate the system here.
Let's cover emergency electrical configuration. First, how do you enter emergency electrical configuration?
With a loss of AC bus 1 and 2.
Okay, what do you have available while the RAT's being deployed?
During the RAT deployment, there's 5 seconds in there where you only have 2 batteries and 2 buses and 2 displays. The 2 buses are the essential AC bus and the essential DC bus. You don't have the sheds. Because of that, you only have the captain's PFD and the upper ECAM.
What are some items that the first officer and captain also have available?
They've got RMP1 and they've got ACP1 and 2.
Any lights for the first officer?
Sure, the first officer's got the dome light, the right dome light if the dome light switch is out of the off position. He's also got, both the crew, have the standby compass light, and then the captain's got the glare shield lights.
After 5 seconds, the rat automatically deploys. What powers the emergency generator?
The emergency generator is turned by blue hydraulic pressure, and that pressure is maintained by the ram air turbine that's pressurizing the system.
And what do you have available now as far as displays and buses?
Well, once the emergency generator comes online, you've got 4 buses and therefore 4 displays. The 4 buses are the essential AC in its shed and the essential DC in its shed. The 4 displays are the PFD, the captain's PFD, the captain's ND, the upper ECAM, and the number 1 or the captain's MCDU. You still also have the RMP and the 2 ACPs.
When will you lose the emergency generator on the 319 and 320?
Well, on 320, it's gear down. On a 319, it's when you get below 125 knots.
Okay, that's occurred. We're back to battery power, and you land, and you get below 100 knots.
Below 100 knots, the batteries connect to the DC battery bus.
What occurs at 50 knots?
Below 50 knots, you lose AC essential bus, and therefore you lose all the displays. You still have the ability to communicate through the AC essential.
You're on the approach, you go gear down, you go back to battery power. 2 batteries, 2 buses, 2 screens. Tower says, Unite 320, go around. Positive climb, gear up. Does the emergency generator come back online?
Unfortunately, no.
You look at the overhead panel, and you see a red fault light. What is that an indication of?
That indicates that the emergency generator is not powering the system, and it should be. The nose gear is up, and that you have no AC power.
So how do you get the emergency generator back online?
I'm going to lift the man-on cover and select the switches under there.
GPWS. To the left, on some aircraft, some models, you have a terrain switch. Describe to me that terrain switch and the system switch for the GPWS.
Okay, the terrain switch is for the eGPWS only, and that's basically an on-off switch. If I select it off, I lose eGPWS capability, but I do not lose GPWS. When I select that eGPWS switch off, I don't have the pop-up feature, I don't have the terrain on ND, I can't get any of those features. But GPWS still works 100%. If I selected the GPWS system switch off, then that will deactivate GPWS, but it does not affect eGPWS. By selecting the system off, or even if I have a fault, I don't get any modes of GPWS at all.
When would you select glide slope mode to off?
If I were flying a localized approach to a runway that had an ILS where the ILS was either out of service or unreliable.
What about the flap mode to off?
Anytime I was landing in an abnormal flap configuration, I'd select that off. It prevents the too low flap GPWS alert.
Finally, landing flap 3 on.
Landing flap 3, I select at any time I'm doing a flap 3 landing. What that does is it suppresses the landing flap GPWS when it expects full flaps. What it also does is it allows the landing memo to change to green when I get flaps 3 instead of staying blue waiting for flaps full.
Recorder panel. Ground control switch in auto. With it in auto, when does the CVR begin to work?
It begins to work anytime, or 5 minutes, for the first 5 minutes after initial power on. It'll also work anytime in flight. It'll also work anytime after the first engine start, which is a good little technique. If you forget anything, throw out first engine start or green dot.
It's going to be one of those.
It's going to be one of those two.
Why would you select the ground control switch to on?
Because the FARs require us to record with the recorder from the reading of the first checklist. Since the automatic portion of it shuts off after 5 minutes, and we read the checklist prior to the first engine start, then we have to turn it on for us to be able to record it.
When you select it to on, what happens when you start the first engine or after first engine start?
It reverts to the automatic mode and the on light extinguishes.
How would you use the CVR erase switch? What would
Just have to be on the ground with the park and brake set.
What about the CVR test?
You need to be on the ground, park and brake set. You need to have the power to the CVR so that way it can do us a little test. If I didn't get the test to work, I'd first check the parking brake, because maintenance might have chocked the wheels and then released the parking brake. So before I called them, I'd look down to see if the parking brake was set. If that didn't work, I'd check the circuit breaker. If that still didn't work, I'd call maintenance.
On the oxygen panel, when will the passenger oxygen system deploy?
Whenever the cabin altitude exceeds 14,000 feet.
Could you manually deploy?
Sure, I'd lift the switch up and then select the button that's underneath there. As a neat aside here, you'll notice that some of these switches have white boxes around them and some of them don't. For instance, this forward smoke over here does not have a white box, neither does the aft. That means these are not switches. Ones that have white boxes around them mean that they are switches.
Crew supply switch.
That basically just cuts off the oxygen to the crew masks in the cockpit.
Calls. Describe to me the mechanic forward and aft call push buttons.
The mechanic is just a horn down below, and it lets the mechanic know that you want to talk to him. So he'll come over and yap at you. The forward and the aft is for the cabin. If I press the forward, they'll get a single ding, and then at the flight attendant panel up front, it'll say that I've got a cabin attendant call, and they're going to answer the phone. Unfortunately, on this airplane, we can't conference call by using the forward and aft calls, and when they call me, we can't conference call. Really, the only way you can conference call with the people in the back is by selecting emergency to on. That'll give 3 dings in all the stations, and they can all get on and talk as a conference.
What if you were to get the amber call on the emergency switch?
That means that they are emergency calling me from the back.
APU. You've selected the APU master switch to on, and you selected the start switch to on. When do you get the avail light?
The avail light comes on, and the on light goes out at 95% in, and the avail light indicates that either electrics or pneumatics from the APU is available.
How does this avail light differentiate from the avail light that you find on the external power switch?
Well, the avail light down here just means that either electrics or pneumatics are available. Up here means that electrical power, external power is available, and it's good power to be taken on the ship.
So what's supplying the electrical power in this case?
If I see avail and avail, then I know that the APU is supplying power, because the on light down here just means that the APU is starting, so it should be up. The on light up here indicates that the external power is on. So with an absence of the on light here, the APU must be powering the aircraft.
What about fault in the APU master switch?
It just indicates that an abnormal APU shutdown has taken place.
Do you know what type of shutdown has
No clue.
occurred? Ditching switch. What occurs when you select the ditching switch to on?
As crazy as it sounds, my instructor told me this, and I have never forgotten it. There are valves that close. There's the avionics inlet and extract, the 2 pack valves, the ram air valve, and the outflow valve. The outflow valve only works if the pressurization system's in auto.
Can you think of a time in normal operations that you might use the ditching switch?
During de-icing.
For cabin pressurization, with the landing elevation selector in auto, where's it getting the landing elevation from for auto pressurization?
From the FMGCs.
Is there a time that you might take that selector out of auto?
Yeah, anytime that I can't get the information from the FMGCs, which is either with a dual FMGC failure, or if the destination is not in the FMGC database.
You have fault light, mode select switch. What's happened here?
That indicates that System 1 and System 2 auto pressure control has failed.
Okay, so you select manual, and now how you get control pressurization?
With the manual vertical speed control switch.
You take the selector to up. What are you doing?
Up means I want to raise the cabin altitude, so I'm going to open the outflow valve to decrease pressure.
Probe window heat. With the switch in auto, when is the probe and window heat activated?
The probe window heat in automatic will start with our favorite phrase, after first engine start. After first engine start, all the probes in window heats are heated in low, with the exception of the TAT probe.
When would they go to a high or flight mode?
When we go when we're in flight, they shift to high, and then the TAT probe is also heated.
What if I was to select the switch to on?
Selecting the on only really does something between power on and the first engine start. and all I'm doing is commanding low power to the probes and window heat, with the exception, of course, of the TAT probe.
Engine anti-ice. You select engine anti-ice to on. What are you heating?
The engine itself.
Anything else occur?
Yeah, you get automatic ignition.
What about fault light in engine anti-ice?
That indicates a valve in transit or a valve disagreement.
Wing anti-ice. You select wing anti-ice to on. Where are you getting the heat for the leading edge, and what is it anti-icing?
The bleed air manifold is supplying the air, and it's anti-icing the 3 outboard slats.
Fault line in a wing anti-ice?
Indicates that there is a valve in transit, a valve disagreement, or a bleed leak.
Good. Pack flow selector valve. You have 3 positions: low, normal, high. Describe to me the pack flow selector valve.
In low, I would select the low whenever I had a passenger load less than 115 passengers. I'd select the high anytime I had a situation where the packs weren't supplying enough cooling to the back. Anytime I shifted to low and the system thought it needed more, it would shift higher. In other words, if I'm on single pack operation or if I'm using APU bleed, it would shift higher. If I were in high though, it'll never shift lower.
Pack 1. With the system on, when would the pack flow valve open?
When there's sufficient bleed air to open the valve.
What about fault light on pack 1?
Fault light on pack 1 indicates that there is a over temperature or a valve disagreement.
Engine 1 bleed. Again, switch is selected to on. When would the engine bleed open?
Again, when there's enough pneumatic pressure to open it, as long as the APU bleed is closed.
Fault on engine 1 bleed?
This is probably the hardest light and switch to remember out of all of them. It's the overpressure, over temperature, or a bleed leak, and then there's 3 valve disagreements. If the APU bleed valve is open and the engine bleed is open, it'll give you a fault. If the engine bleed valve is open during engine start, or if the valve disagrees with the position of the switch.
Ram air. It's a guarded switch. You select ram air to on. What occurs?
The ram air inlet opens up.
Okay, it ducts outside air into the mixer unit. What would happen to the outflow valve?
The outflow valve will open whenever the PSID is less than 1 PSI.
APU bleed. APU is available. You select APU bleed to on. Describe to me some valves that will open, valves that will close.
Okay, when the APU bleed valve is open, the engine bleed valves will close, and the cross bleed valve, if it's an auto, will open.
What about fault on APU bleed?
APU bleed leak only.
The cross bleed selector, you told me with the selector in auto, it takes the same position of the APU bleed valve. However, what if I command shut or open?
Shut or open is going to give you a shut valve or an open valve.
Hot air valve.
Both of these indicate a overheat or a valve disagreement. In this case, it's a duct overheat. In this case, it's a pack overheat.
Electrical panel. What is the electrical priority?
The priority is on-site generator, on-site engine-driven generator, the external power, APU generator, and off-site engine-driven generator. What I mean by on-site and off-site, let's just use for AC bus 1, the on-site generator is Gen 1, the off-site generator is Gen 2.
Based on that electrical priority, external power is on, you have the APU available. How do you get the APU generator online?
You have to deselect external power.
Let's talk about the galley switch. Fault in the galley. What does that indicate?
Indicates that any generator that is an engine-driven generator or the APU generator has a load in excess of 100%.
Doesn't it shed the galleys completely?
No,
Or by shed automatically?
no, the galleys are not shed until they're not shed. You have to select the switch to off.
And then what occurs? Galleys are...
The galleys are unpowered.
Fault in IDG.
IDG fault means that the IDG oil temperature or oil pressure the temperature is high or the pressure is low.
Any cautions to selecting an IDG?
Yeah, don't press it for more than 3 seconds, and don't press it if the engine's not turning.
Fault on Gen 1.
Indicates that the GCU has detected a protection fault, or the line contactor is not closed and the switch has commanded it to close.
Batteries. What is our minimum battery voltage?
Min battery voltage 25 volts. However, at 22 volts, if it's 22 volts or less for more than a second, the batteries will disconnect.
Is there any tests that the crew might perform for the batteries?
Yeah, the captain is going to select the batteries off, look on the electrical page, and then select the batteries back on. He's going to check to see that the amperage is 60 amps or less, and it's decreasing within 10 seconds.
What about fault in the battery switch?
It's just an abnormal charging rate.
Below, I see a title that says AC Essential Bus. What normally powers that?
AC bus 1 is indicated by the thick arrow here on the schematic.
And what if you got a fault light in AC Essential feed?
That means that AC Essential bus is unpowered.
Okay, how could you restore power back to that AC Essential Bus?
Select alternate on this switch, and that'll allow AC bus 2 to power AC Essential bus.
The bus tie switch, when it's in auto, it's giving us our electrical priority, but what about selecting it to off?
Selecting it off basically isolates the system and allows generator 1 only to power AC bus 1 and AC bus 2 to be only powered by generator 2.
Walk me through a loft scenario in which we have fuel in all the tanks, all the switches are in, and the mode select is in auto.
Okay.
Starting with pushback.
Okay, so full tanks is going to be 43,000 pounds. And we
Okay.
know that that's going to be 14, 15, and 14. So with 14 and 14, that's 28. Anytime I have more than 28,000 pounds, I'm going to have fuel in the center tanks. So I push back and I start the engines. The center tank pumps are going to run for 2 minutes after engine starts, regardless of the slat position. So I taxi out now. As soon as I move the slats to, or the flap handle out of up, the slats are going to come out and the center tank pumps are going to shut off. I'll take off. When I raise the flap handle to 0, the slats are going to retract, and therefore the center tank pumps can again resume their operation. This will happen until we burn out all the fuel in the center tank. If that happens, the center tank pumps will run for 5 minutes, and then. But let's say we get to my destination and I still have fuel in the center tanks. I'll move the flap handle out of up, and the slats are going to come out. This will cause the center tank pumps to stop running. When I land, they'll still be stopped until I bring the flaps up. The slats will retract, and then the center tank pumps will then again be able to run.
In that scenario, let's assume that you burn the center tank fuel. It sends low level. Did the center tank pump shut off right away?
No, they'll continue to run for 5 minutes.
After 5 minutes, they shut down. You're burning your inner wing tank fuel. When would the transfer valves open up to allow the outer to spill into the inner?
When it senses less than 1650.
Okay, is that both of them have to get to 1650 or the first one?
No, whichever one gets to 1650, there's 4 valves, 2 in each tank, and they're kind of cross-related. So if I get below 1650 in the left wing, 1 valve in the left and 1 valve in the right will open up and will allow the fuel to flood into the center tanks.
Will they close after that happens?
Or the inner tanks. No, they won't close until you refuel the aircraft.
Going back, you're in flight, you have fuel in all the tanks, and you get a fault light in the mode select switch. Walk me through to how you could possibly get into this scenario.
Okay. Well, first of all, the IDG oil is cooled from the fuel return lines. So some of the fuel is spun through there, and it cools it off, and then it spills back into the outer wing tanks. When the outer wing tanks are full, it'll spill to the inner wing tanks. Once that senses that it's full, the system will then shut off the respective center tank pump and allow that wing tank to burn down 1,100 pounds. But if it doesn't stop, and if the center tank pump doesn't start up again, and it allows the inner wing tank to burn down, it'll then cause this fault to occur. The fault light illuminates whenever the center tanks are greater than 550 pounds, the wing tanks are 11,000 pounds or less, and
would the center tank pumps be operating?
the center tank pumps would be off in that case, and they should be operating.
So the auto feature has failed. How would you continue to burn that center tank fuel?
I'd select the switch to manual and allow it to run just like the wing tanks.
Fault lights. Describe to me a fault light in a wing tank pump.
A fault line in a wing tank just means that there's low pump pressure.
Fuel numbers. Are there some numbers associated, some limitations that you can come up with for
Yeah.
the fuel system?
Yeah, we've got a new one at United is the fuel imbalance. It's changed to 3,300 pounds. Another one we have out there is the minimum desired landing fuel, which is 1,600 pounds, broken down to 400, 800, and 400 for the 400 for the landing or at touchdown, 800 for the go around, and 400 for the fuel gauge air.
That 3,300 fuel imbalance, is that all phases of flight?
No, that's only for takeoff and landing.
Hydraulic panel. Starting with the green system, how many ways to pressurize the green hydraulic system?
Just the engine-driven pump.
Anything?
And, well, the PTU backs it up.
How many ways to pressurize the blue hydraulic system?
Either the electric pump or the ram air turbine.
The blue electric pump, with the switch guarded and the switch in auto, when does the blue electric pump begin to pressurize the system?
Let me see. First engine start?
Very good. First engine start.
Amazing.
How many ways to pressurize the yellow system?
There's the engine-driven pump, the number 2 engine-driven pump. There's the electrical pump, and then again the PTU.
Can you describe to me this PTU?
Yeah, it's a power transfer unit, and it operates between the yellow and the green system. Whenever there's a difference between the yellow or green system of greater than 500 psi, it'll allow the other system to pressurize the low system.
Is there any fluid transfer with this?
No, there's 2 reversible motor pumps that are on here, and the yellow, for instance, let's say we have a low green system pressure. The yellow system will drive that motor pump, it'll drive a shaft, the reversible motor pump will drive a shaft to the other motor pump, and it will then pressurize the green system. So there's never any exchange of fluid.
4 conditions for a fault line on engine 1 pump. 3 are associated with the reservoir. What are those 3 reservoirs?
A low air reservoir pressure, low quantity, and over temperature.
Would you get a fault light with one of those 3 conditions in the PTU?
Yes, I would. The PTU is only designed to help for low pressure in the system, so it wouldn't want to operate the system with a bad reservoir.
Finally, the 4th condition for the fault light
Is low pump output pressure.
in which case this is what the PTU is designed for.
Yeah.
Wrap man on. You told me on the emergency electrical panel that selecting wrap man on, I would get if the rat didn't deploy, the rat should deploy, and I would get the emergency generator. Would I get the emergency generator with that wrap man on?
No, this is just a manual on switch, and this is going to not only deploy the RAT, but it's going to open up a second valve that'll allow the emergency generator to be powered. Over here, we're only opening one valve when we do it, and it just allows the system to pressurize the blue system, but has nothing to do with the emergency generator.
Are you inhibited from selecting that on the ground? Is there
I
an
personally am inhibited from doing it because I am inhibited from killing somebody. However, there is no system protection to keep me from whacking somebody in the head with that big spring out there.
Fire detection. Describe to me what occurs when you select an engine fire push button.
When I release that fire push button, we have a little gouge we use, which is 21212. On the top, we start with 2. The 2 squibs are going to be armed, as well as the warning is going to be canceled. On the hydraulic panel, the hydraulic fire shutoff valve is closed. On the fuel panel, we've got 2 things. The low pressure fuel valve is closed, as well as the fuel return valve. On the electrical, we deactivate the generator, and then on the air conditioning, we close the engine bleed valve and the associated pack valve.
What about for the APU fire push button?
APU, we can still use 21212. It's just a little bit more awkward. First of all, with will arm the squib and still silence the warning. There's nothing hydraulically that goes on, but we have to remember that it shuts down the APU using the ECB, and what that does is it sequences the shutdown for us. The fuel, it shuts off the APU fuel pump as well as closes the fuel line, and the electrical, it deactivates the APU generator, and on the air conditioning, it closes the APU bleed valve, and because this valve is closed, and if this is an auto, the cross bleed will also close.
You're on the ground, the APU's running, and it detects a fire. Do you have to be there to monitor it, or what occurs when APU fire on the ground?
No, on the ground, the APU will automatically shut down, and the fire sequence will take place.
What about an APU fire in flight?
No, it allows you, it'll be just like an engine, it'll continue to run because it knows that you want to direct the shutdown.
Anything that you're concerned with if you're on battery power only?
Battery power only, you only have Agent 1 for each of the bottles. Of course, APU only has one, so that one's available.
Audio switching. There's a selection for Captain on 3 and FO on 3. When would you use this?
With the Captain on 3, I would use that when the Captain's ACP has failed and he wants to use the number 3 ACP, audio control panel.
What are green circuit breakers?
Those are ECAM monitored.
What about the black ones?
They are non-ECAM monitored.
I notice there's 2 yellow bands. One's labeled PIDO number 1 for the antis and AOA number 1. What are those yellow banded circuit breakers for?
They are for the emergency electrical configuration on the A320, and it's for if we're on battery power and we need to extend the battery life. If we're in VMC and not concerned about icing, we can go and pull those circuit breakers.
Okay. Will you find those circuit breakers on the 319?
No.
Yes, you will. What about the yellow band?
No, that won't be on the 319.
And why is that?
Because on the 319, the rat's going to be operating all the way down to touchdown, so we won't ever be operating on the battery for a long length of time, so we don't need them.
Overhead maintenance panel, anything that you're concerned with that panel?
Only if I see a light up there. If I see a light, I'm going to be calling maintenance, but other than that, no.
Cargo heat. You have a hot air and an aft isolation valve.
Pretty simple. Hot air means it's too hot. It's an over temperature. Aft isolation valve disagreement.
Cargo smoke. On the 320 you have 2 bottles, and let's say you get smoke in the forward cargo compartment. Kind of walk me through what you're going to do.
Well, I'm going to follow ECAM, and basically it's going to tell me to discharge Agent 1 in the forward pit. So I'm going to lift the guard, and I'm going to move the switch to Agent 1.
What occurs after 60 minutes?
60 minutes later, you're going to get this light here, discharge Agent 2. And that's just a reminder that you need to discharge the second agent into that pit. It's not going to automatically do it for you, it's just a reminder.
If you discharge Agent 1 into the forward cabin, can you discharge Agent 2 in the aft if you were to get smoke in the aft cabin?
According to the procedures in the United Flight Manual, you cannot discharge Agent 2 into the aft pit in this case.
So wherever the first bottle is dedicated, second bottle is dedicated.
According to the UAL Flight Manual, that's correct.
Ventilation. You have a blower and extract. Describe to me blower fall versus the extract fall.
Well, first of all, selecting either one of these to override is going to introduce air-conditioned air to the system. However, when I select the blower to override, it's going to shut the fan off. It's an on-off switch. If I were just to select the extract fan to override, then the fan is going to continue to run. It is not an on-off switch.
What about the scenario of taking both to override, and when would you might do that?
Well, to do that, I'm more than likely, I've got a smoke light over in the Gen 1 line switch. And by selecting these both to override, I'm going to the smoke configuration. I'm still introducing air-conditioned air to the system, but I'm basically venting it overboard.
On the engines, N1 mode. When might you select N1 mode, and what's our procedure?
Well, the IE, the 2500 is a EPR rated engine. So we run around in EPR rated mode all the time. it's possible for us to fall out of EPR mode if the FADEC has a problem. So what we would see is more than likely one engine would go into an N1 mode, either rated or unrated. And there are various indications down here that are going to tell us where the TLAs are and such. If I'm in N1, or if one engine falls out of EPR mode and goes into either N1 rated or unrated mode, I need to select both of these switches to on. I need to force them both into N1 mode. If I'm forcing an engine into N1 mode, I can only force it to an N1 rated mode. To get to an unrated mode, it has to degrade. So when I select the good one, into N1 mode, I can then, if I have an unrated situation on the bad engine, I can match the two thrust levers up, or not the thrust levers, but the two engine indications up to protect myself on the weak engine. If both were to fall into N1 unrated mode, I'd have to use flight manual computations to determine what my thrust settings would have to be.
Would you have auto throttles available in N1 mode?
No, auto throttles are not available when I'm in N1 mode, and therefore I lose alpha floor protection.
How do you know you're in N1 rated versus N1 unrated?
In N1 rated mode, I'm going to have it's going to say N1 up here and give me percentage signs and such.
Unrated?
Gone.
Amber X's.
Amber X's.
Thus no overboost protection.
Correct.
Describe to me the parameters in which you get an auto land light.
Okay, auto land lights only occurs during an auto land approach, and it's armed at 200 feet. There are three things that are going to illuminate the auto land light. From 200 feet all the way to the ground and rollout, if I lose both autopilots, not one, but both autopilots, the auto land light's going to come on. If I were to go from 200 feet down to 15 feet, the localizer, if it's lost, or if I deviate by more than a quarter dot, it's going to illuminate the auto land light. And then from 200 feet down to 100 feet, the glide slope, a loss of or a deviation by 1 dot or more, is going to illuminate the auto land light.
A red master warning. You get a red master warning, repetitive chime, and this is a level 3 ECAM. Are there some times that you might have an inhibit of master warnings or even certain ECAMs?
Yes, there's the takeoff inhibit and the landing inhibit. The takeoff inhibit, we've got a list of items that are included on the takeoff inhibit. Those are basically things that are not inhibited, are like engine fire, engine failure, or imminent engine failure with a loss of oil pressure. If I have a rudder or an elevator problem, a left and right elevator problem, a dual FWC fault, or if I have a AP fire.
How about if the autopilot kicks off?
The autopilot kicks off is really a player for after we've taken off and I've engaged in autopilot. We don't want to inhibit it up to 1,500 feet like the rest of them are, so we just don't inhibit it. If I take off and start a turn and the autopilot kicks off, we still want to know about it. So that one is one of the strange ones that hangs out there.
Takeoff inhibits active
From takeoff power application up to 1,500 feet.
your FCU panel. Starting left to right, walk me through the FCU panel in which you get managed speed versus selected,
Sure.
heading versus LNAV,
Sure.
and so forth.
So basically we've got these buttons here. There's these 4 buttons, or knobs, truly. Whenever I push, I'm basically telling the airplane to calculate what I want. And I'm asking for a managed mode. When I pull, I'm saying, I've got it, I want it, select it. So I'm selecting it. So whenever I push, I'm asking for a managed speed. If I pull here, I'm asking for a selected speed. Okay? It has no relationship to, like the Boeings have this VNAV and the econ speed. There's no relationship of managed speed to the VNAV portion. We can get managed speed in any vertical mode or no vertical mode whatsoever. Okay? So pushing is a managed speed, pulling is a selected speed. With the lateral portion of it, pulling is giving me a heading or a track if I'm a track flight path angle. Pushing it is asking for LNAV. Under the altitude, Pulling is asking for an open climb or open descent, depending on whether or not the altitude's higher or lower than what my current altitude is. Pushing is asking for climb or descent mode. Now pushing it only will work if I've got nav mode engaged. And then the last one is the vertical speed knob. Pulling it is asking for a selected vertical speed or flight path angle and track flight path angle. If I pull that, it's going to come up into whatever my current vertical speed is, and then I'm going to dial it around. Okay? If I push it, it's asking for a vertical speed of 0. That doesn't mean the airplane's going to level off the altitude I pushed it at. It means it's going to decrease its vertical speed to 0. So if I push it, and I'm doing 2,000 feet a minute in a climb, as I pass 3,000 feet and I push it, it's not going to come back down to 3,000 feet. It's just going to level off wherever it achieves 0 VSI.
Describe the difference between the loc and the approach push button.
Okay, the loc is only used on an ILS system where the localizer is capable, and that's going to track the localizer course down. The approach button is used for an ILS system or for a non-precision approach for VOR NDB in our database at United. The approach will, during an ILS, will arm both the localizer and the glide slope.
Is there any caution to that?
There is a slight caution. The policy at United right now is when we're clear the approach, we can arm the approach button, but we have to ensure that we won't capture the glide slope and start down until we've captured the localizer. So the caution really would be to ensure that you do not descend until engaging the localizer.
Like on the FCU, there's a push button for metric altitude. What would happen if you select that?
By selecting that, I would not change the altitude over here to meters. It would stay feet. But down here, just above the clock, would give me a metric altitude in meters.
What about the altitude selected in the FCU? Would that change to meters?
That's still feet.
On either side, there's a side stick priority. There's an arrow. On the first officer side, there's an FO. On the captain side, there's a captain. Explain to me side stick priority and the indications.
Okay, first of all, we've got the button on the side stick. And what that does, if we just click it one time and the autopilot's engaged, it'll disconnect the autopilot. Problem with just clicking it one time is it'll give us the master caution, an oral warning, and we'll get a ECAM. If we click it twice, though, it will give us the master caution sound, but the ECAM won't come up and remain up there. It automatically clears that ECAM. If I click and hold that button for a short period of time, I'm going to hear the word, and in my case, as a first officer, I'm going to hear priority right. And what that means is that the captain's stick is now deactivated. It can no longer make inputs in there. If I let go of it at this point, then the captain's stick then becomes reactive, and it's the same summation that typically goes on. If I press and hold it, though, for approximately 30 seconds, then it will latch out the captain's. In other words, I can let go of it after that, and then the captain's stick will still then be locked out. The captain can get his control back by either of us pressing our buttons. As far as the lights go up here, whenever I get priority, I'm going to go, or the guy on the other side is going to get a red light. And then if he went and then subsequently moved his stick, then I would see a green FO in front of me indicating, hey, first officer, you have control of the aircraft, but the other guy is still moving his stick.
Landing gear. What hydraulic system controls the landing gear?
The green system.
What are some other components for gear that the green hydraulic system controls?
The normal brakes.
Okay, normal brakes.
Nose wheel steering.
Nose wheel steering. Landing gear panel. Talk to me about some of these indications that you find on the landing gear and where are they coming from? Okay,
the landing gear on the forward panel right here is coming from the LGCIU-1. And what happens is the signal is sent up through LGCIU-1. LGCIU-1 doesn't really process it. It just basically passes through LGCIU-1 and then displays information here. On the ECAM, though, we've got two indications. And one of them comes from LGCIU-1, the other by LGCIU-2. They're independent. They go through the LGCIUs, are processed, and then passed on to the ECAM. LGCIU, by the way, stands for Landing Gear Control Interface Unit.
Any speed restrictions with the landing gear?
Yeah, there's three big ones that are in the limitation section. It's 220 knots and 0.54 for gear retraction. for gear extension is 250 knots and 0.60, and then for gear extended, it's 280 knots, 0.67.
While we're on gear, what are some tire pressure limitations?
As far as tire pressure, we've got the nose wheel, which is always 180 psi. For the 320, the main landing gear is 210. For the 319, it's 187.
Let's assume that the green hydraulic system failed, the landing gear is up. How can we extend the gear? And is this an ECAM procedure or a non-ECAM?
This is a non-ECAM procedure. You'll get a note in the ECAM on the hydraulic failure to say you'll have to manually extend the gear, but the procedure itself is in the irregular section. And to do that, basically you're going to have to crank the gear down. It's 3 turns and it's a pretty easy one. I don't even know what each turn does, I just know that I got to crank it 3 times.
Okay, after cranking it 3 times, what would you do to not get some of the jib whiz warnings?
I'm going to go ahead and put the gear handle down.
Match the gear handle with the gear.
Another idiosyncrasy with this cranking the gear down is that I'm going to lose the nose wheel steering.
Let's talk about brakes, starting with auto brakes. Walk me through low, medium, max, when you would use these.
Okay. Auto brakes are only available in the green system, and I'm going to use low for most of my landings. I'm going to use medium anytime my landing distance is increased, or anytime I'm low vis ops like a Cat 2, Cat 3 ops. And I'm going to use max during takeoff.
When does auto braking occur?
With low, well, first of all, the signal is the spoiler deflection.
Okay.
For 4 seconds after in 4 seconds after the spoiler deflects, low is going to occur. 2 seconds for medium, and immediately for max.
What about the decel light?
Decel just means that we've achieved 80% of the deceleration rate that we're looking for. By the way, we don't have to achieve that deceleration rate with the brakes. We can do it with reverse thrust or any other source. As long as that deceleration rate is occurring, it's happy. If we're not meeting that deceleration rate, it will then start to engage the pucks.
Brakes. What are some brake temperatures that you're looking for before takeoff or even taxi in?
Before takeoff, we have to have, the maximum for takeoff is 300 degrees. On taxi in, we're looking for 3 different ones: 60, 150, and 600. 60 degrees is on any brake, we need to have 60 degrees. If it isn't, then the puck never engaged. 150 degrees is the difference between the pucks on each truck. Be within 150 degrees of each other, or they're working asymmetrically. And then 600 is the maximum on taxi in.
Triple gauge indicator. What kind of system pressure does that indicate?
Indicates yellow system.
Yellow system. Let's start with push back. You set the parking brake, tow bar is disconnected, and the airplane starts to move. How might you stop the airplane?
Well, if the parking brake switch is set, the tow brakes are basically deactivated. So I have to release the parking brake handle and then try to get on the normal brakes.
New day, you're taxiing out, captain goes to do a brake check, should have normal brakes, applies the brakes, and the airplane's not stopping. What might you do? And what are some cautions to doing this?
Sure. Well, the first thing I do is get off the brakes, and then I'd also make sure I don't have any steering inputs in there, because when I do the next step, I'm going to get rid of my nose wheel steering. I'll reach up, turn the anti-skid nose wheel steering switch to off in hopes that the alternate brakes are going to stop the aircraft.
What if the alternate brakes won't stop the aircraft?
Well, if that doesn't, you're going to have to hope and that the parking brake's going to work. So you reach down, turn the parking brake on, and that's going to stop you pretty abruptly. Flight attendant, corner pocket.
Normal brakes is done through the green hydraulic system. What would occur if you lost green hydraulic system?
I'd lose normal brakes.
Okay. You've lost green hydraulic system. The BSCUs are still working, so that should force you into alternate brakes.
Correct.
BSCU brake steering control unit, provided you had that still available, you should still have anti-skid.
Yeah.
What about the scenario of losing both channels of the BSCU, but we still have green hydraulic system?
If I've got green hydraulics, but I lose the BSCUs, I still lose my normal brakes, and I lose anti-skid capability.
Okay. Since you can't detect brake pressure, we've lost anti-skid, but we can't detect brake pressure being applied in normal brakes. It's going to force us into alternate brakes without anti-skid because of loss of the BSCUs.
Right.
What is your anti-skid detection now?
It's basically your first officer's eyes on the brake triple gauge, making sure that he doesn't have excess of 1,000 psi.
This red down arrow on the landing gear panel, explain that to me.
That indicates that the gear is not down, and it should be. It's accompanied by a warning horn, and it occurs 3 times. Below 750 feet, and the thrust is below 75% in one on 2 engines, or below 97% on 1 engine. Or if I'm below 750 feet, gear's not down, and the flaps are 3 or full. Or in the event I have a dual altimeter failure, it can't tell what altitude I'm at, so anytime I don't have the gear down and the flaps are at full.
On the ECAM panel, we have a takeoff config. What are you doing when selecting the takeoff config?
I'm simulating that the thrust levers are applying takeoff power in order to test that all the configuration parameters are met.
What are some of those configuration parameters that are
That-
checked?
That would be the flaps in the takeoff range, the pitch trim in the takeoff range, the spoilers are armed, and the rudder trim on the later A320s and on all the 319s. We also check for the side stick fault by takeover, the doors not being closed, and the brake temps.
Okay. What are some items that advancing the thrust levers for takeoff checks, but the takeoff config does not?
That would be the parking brake being set, because we want to be able to do the configuration test with the parking brake set, and the flex temp not set.
Emergency cancel, and let me break this down into 2 parts. You get a level 3 repetitive chime and a master warning, but instead of selecting the master warning here to silence the oral, you select emergency cancel. What does the emergency cancel do in that scenario?
It just silences the master or the continuous repetitive chime. That's all.
So what's the difference between selecting master warning here and emergency cancel?
Some of the master warning CRCs cannot be canceled with the master warning switch. You have to do it with an emergency cancel.
The other part of the question is you get a level 2 single chime master caution, and instead of selecting the master caution to reset for the next ECAM, you select emergency cancel. What occurs now?
Well, now you've suppressed the ECAM, and on the lower ECAM, on the status side, or on the inoperative system side, it'll give you a list of ECAMs that have been suppressed via the emergency cancel. And if that reoccurs on the flight, you won't be notified about it.
Okay, so let's assume that we cancel a caution.
Sure.
Everything goes back to normal screen configuration. You pull out the status page, you see canceled caution and the title for the ECAM that you just canceled by selecting emergency cancel. You go, I really didn't want to do that. I want to run that ECAM. How could you bring that back?
I'd press and hold recall, and that will clear all the canceled cautions and allow all cautions to then be alerted through the master caution system.
On your MCDU, on the first officer side right here, we have the performance approach page. We have VLS that displays 128. The winds are currently 330 at 15, and you're landing on runway 33. Describe to me what our V approach would be in that scenario.
Okay. On a 320, well, first of all, we start with the VLS.
Okay.
To calculate V approach, on an A320, we add 5 knots and then a third of the headwinds that are installed on this page. So because we're on runway 33 and the mag winds here say 330 degrees at 15, a third of that would be 5 knots. So 128 plus 5 is 133, plus a third of the headwinds, which was 5, which would give us 138 knots.
That would be our V approach. What would be our mini ground speed?
Well, mini ground speed is calculated by taking your V approach and then subtracting out 100% of the headwinds. And in this case, at 330 at 15, that'd be 15 knots. So 138 minus 15 is going to be 123.
That was V approach for the 320. Same scenario, but you're on a 319 today. VLS is still 128. Mag winds are 330 at 15 and runway 33. How's V approach calculated for the 319?
Okay, the only difference in all of these is that on a 319, it'll be VLS plus 5 or VLS plus a third of the headwinds that's set in here, whichever is greater. On the 320, we added both. Here, we're only going to add the higher of the two. In this case, with a VLS of 128 knots, mag winds of 330 at 15 on runway 33, third of those headwinds is 5 knots. 128 plus 5 is 133.
Write to me config 3 versus full.
Okay? We select config full for just about every approach that we do at United Airlines. First of all, most of the landings we do are full, so we want to select full. Anytime I elect to land flaps 3 for just a reason, it's not ECAM driven. For instance, I want to do flaps 3 for proficiency, or if I suspect wind shear and I want to land in flaps 3, I'll select config 3. What this will do is we'll change VLS to a VLS for flaps 3, and then it'll allow me to slow to my managed approach speed when I'm in flaps configuration 3. I do not select config 3, however, if I'm going to land flaps 3 for an ECAM driven situation. The most frequently occurring time this would happen would be during an alternate law and then direct law landing. Alternate law approach, direct law landing. We know that every time I land an alternate or do an alternate law approach and a direct law landing, I'm going to be doing this in flaps 3. If I were to select config 3 here, it would change VLS by approximately 5 knots. And when we go out and figure out our configuration and our approach speeds, that'd be incorrect. We need to base this off of VLS for flaps full because that's VREF. So just to recap that, the only time I select config 3 is when I'm doing it for proficiency or if I elect to do so out of a non-ECAM driven situation like wind shear.
You go to start engines. You go throttles idle, mode select, ignition start. What are some items you're looking for when you take the mode selector to ignition start?
Well, I'm going to look on the engine page and look to see that the two top indicators go from amber X's to their normal indication.
Anything on the lower display?
The engine page will then show up.
Now that your EPR and EGT have gone from amber X's to
The normal display.
normal display, what's being powered now?
The FADEC power.
Okay. Normally, what powers FADEC?
The FADEC has its own alternators.
You went from mode select normal to ignition start. You look for your parameters, and you suddenly get a fault light on engine 1 master switch, but both engine master switches are off.
If I get a fault light, for instance, in number 1, that means there's a disagreement of the FADEC channel A and B with regards to the high pressure fuel valve.
Is there another time when you might get a fault light?
Sure, if I brought the engine 1 master switch up, the fault light would no longer indicate that FADEC problem, it would indicate an abnormal shutdown.
Okay, so for auto starts,
Auto start faults, hot
Auto
start,
aborts.
auto abort.
you get a fault light.
Yeah.
Moving to the spoilers, let's say you're on the approach, you land, and you arm the spoilers. When would you get auto spoiler deployment on landing?
When I get both wheels on the ground and both thrust levers are at idle.
Let's say same scenario, but you forgot to arm the spoilers.
I'd have to get both of them in idle and at least one of the thrust reversers in at least idle reverse.
On takeoff, you abort the start. When would you get spoiler deployment?
With a wheel spin of 72 knots, I'd get a spoiler deployment immediately.
Rudder trim. The LCD readout will display rudder trim, whether the autopilot's engaged or you're manually selecting rudder trim. Tell me how much rudder trim you can command manually versus the autopilot.
Manually, we can command about 1 degree per second. In the A320, we get 20 degrees, so it takes approximately 20 seconds to get that. In an engine out situation, it's between 17 and 20 degrees we want anyway, so we might as well just run the trim over there. In a A319, we can get up to 30 degrees trim, and so that'd take approximately 30 seconds to get full rudder trim. According to the UAL flight manual, it says that the autopilot can provide 5 degrees per second, although I rarely see it go much more than 0.5.
Autopilot's engaged. Will this manual trim switch work or the reset work?
No, I can't manually trim when the autopilot's engaged,
Or even reset?
or even reset.
You take off flaps position 1 plus F. After rotation, you notice that you have an alpha lock indication below the flap number. What is that alpha lock indicating?
Alpha lock, which truly indicates a slat lock, means that I cannot retract the slat from position 1 to up. I can retract it from any other position up to position 1, but I cannot go any less than position 1.
What creates that alpha lock?
Either being in a high AOA situation or low airspeed. And that's how your oral's going to go. Basically, he's going to walk in, give you the performance, let you spend about 20 minutes with it, and then he'll come in and talk about your solution. He'll then go over some of the paperwork, try to figure out that to see that you know what you're doing there. And then he's going to go through the PFD like we did. Of course, in the PFD, he's probably not going to cover everything that we did, but he'll cover a lot of it. When he gets into the overhead panel, he's going to cover 1 or 2 questions per system. If he sees that you know the system, he's going to press on. If he sees that you're starting to falter, he's going to dig a little bit deeper. So it'll do you some good if you know your systems pretty well. And then he'll show you the walk-around video. Walk-around video is like any other walk-around video you've seen before. There's going to be some errors on it, and you got to catch them. Other than that, you're done. Well, we hope this helps you out, and good luck on your own.